Thank you very much, Allison, and thank you to everyone who has joined us today. As Allison indicated, my name is Will Burns, and I'm co-director of the Institute for Carbon Removal Law and Policy at American University. The Institute is a research center at American that focuses on legal, political, and ethical aspects of this emerging suite of responses to climate change that we call carbon dioxide removal or greenhouse gas removal approaches. And while a lot of the initial focus on carbon dioxide removal approaches was on two options, which was afforestation and reforestation, as well as bioenergy with carbon capture and storage, it's become increasingly clear out of sustainability concerns as well as scalability concerns that we will need to enhance and widen our portfolio if we're going to achieve the temperature objectives of the Paris Agreement. And one of the approaches that is increasingly being scrutinized is enhanced mineral weathering, which today's speaker will explain a bit more about in a moment. However, while there's been an extensive amount of scientific research in recent years, there's been very little attention to the critical aspects of legal regulation, either at the national level or at the international level, or at the subnational level of these approaches. And fortunately, today's speaker, Romany Webb, who serves as a senior fellow at the Sabin Center for Climate Change Law at Columbia University, has released a recent comprehensive treatment of some of those regulatory issues. And so we're very pleased to have her with us today to discuss those issues. The way we will proceed is there'll be an initial intervention by Romany to present an overview of the findings from the report. I will follow that up with a few questions, and then we will turn it over to the Q&A with those of you that are attending today. So with that, I'd like to turn it over to Romany, and once again, thank her for joining us today.
Thank you, Will, and thanks to you and the team at the Institute for Carbon Removal Law and Policy for organizing the webinar and giving me the opportunity to present. It's really exciting to be able to talk about this new, somewhat cutting edge issue. I'm going to share my screen, and you guys should be able to see my slides, hopefully. Great. So as Will said, I'm going to talk a little bit about what enhanced weathering actually is and how it might be used, and then also just introduce some of the key legal issues that it could raise. But first, I thought I'd just talk very briefly about carbon removal more generally. This graph will be familiar to many of you. I'm sure it's taken from the Intergovernmental Panel on Climate Change's 2018 special report on global warming of 1.5 degrees Celsius. It shows, of course, that global average temperatures are already about 1 degree above pre-industrial levels and likely to hit 1.5 degrees above pre-industrial levels in the next decade or two. 1.5 degrees is, of course, a key threshold in the 2015 Paris Agreement. The international community set a goal of limiting warming to well below 2 degrees Celsius and ideally to 1.5 degrees Celsius. Since the Paris Agreement was adopted, the Intergovernmental Panel on Climate Change and many others have issued reports which really reiterate just how important it is that we remain within the 1.5 degree threshold and show that warming above that level will have really devastating impacts. Of course, to limit warming to 1.5 degrees Celsius, we need to rapidly and dramatically reduce our greenhouse gas emissions, but as Will sort of alluded to, because we've waited so long to reduce emissions, that's unlikely to be sufficient by itself. We're likely to also need to deploy greenhouse gas removal or carbon removal techniques. The IPCC in its 2018 report modeled various emissions pathways consistent with limiting warming to 1.5 degrees. They all require carbon removal, in some cases fairly high levels of carbon removal starting really relatively soon in the next couple of decades. And Incidentally, you know, even if we don't stay within the 1.5 degree threshold, to stay within the 2 degree threshold, we're likely to still need carbon dioxide removal for that as well. So there are, as Will said, many different approaches to carbon dioxide removal. Enhanced weathering is one of them that seeks to really accelerate natural processes in which silicate-rich rocks react with carbon dioxide. And that reaction releases carbonate or bicarbonate ions, which eventually release carbonate minerals such as limestone. So in effect, the process, the mineralization process, takes carbon dioxide out of the atmosphere and stores it in the form of rock. When it occurs naturally, this process takes quite a long time, you know, can take centuries. And so enhanced weathering is really looking at ways to accelerate it. The principal idea is that you take reactive materials, the reactive rocks, grind them to increase their surface area, and then apply them to land or ocean waters. Recently, there's been quite a lot of interest in the possibility of enhanced weathering on agricultural land. That's seen as particularly promising for a couple of reasons. One is that it's relatively easy to apply the reactive materials to agricultural land. Agricultural producers already apply things like fertilizers and other substances, and the same equipment could be used to apply this sort of rock powder. Also, research has shown that some of the materials proposed for use in enhanced weathering actually operate a bit like fertilizers and stimulate plant growth. So that could be an additional benefit. The carbon sequestration potential is really quite significant. I've hyperlinked on this slide a 2018 study, which was really interesting, found that performing enhanced weathering on suitable croplands globally, and that's principally croplands in sort of warm and humid climates, that could sequester as much as 95 gigatons of carbon dioxide each year. And to put that figure in perspective, current energy-related emissions are about 33 gigatons per year. So we're talking about sort of 3 years worth of emissions each year. And that is, as I said, just on croplands. We could also, in theory, do enhanced weathering on other type of lands like forests and coastal areas. And we could also do it in the oceans. Now, all of that is not to say that enhanced weathering is sort of the one solution to all of our climate problems. It does have some drawbacks, and one of them is cost. Depending on the materials used and where enhanced weathering is performed, the cost can be quite high. I've put on the slide some of the materials that are commonly discussed for, or commonly proposed for use in enhanced weathering. By far the most widely discussed is dunite, which is an ultramafic rock comprised almost entirely of a substance called olivine. It's a green substance that's a magnesium ion silicate, and because dunite has this really high silicate content, it has really high carbon sequestration potential. Studies have suggested that it could sequester about 1.1 tons of carbon dioxide for each ton of rock used, and the cost would be about $60 per ton of carbon dioxide sequestered if you did that on agricultural lands. That might not sound too bad, but it's actually quite a bit higher than other commonly discussed carbon removal techniques like afforestation, BECCS, which Will mentioned, and also some forms of direct air capture. The other thing about dunite is that it can contain heavy metals like nickel and chromium, and so there are concerns about the potential for soil or water contamination if dunite is used for enhanced weathering. That is less of an issue with some of the other materials that are proposed for use in enhanced weathering, rocks like basalt and wollastonite, which also contain silicate, but in smaller amounts than dunite, which is why the carbon sequestration rate is lower, you can see, and the costs are higher. I will say, you know, both studies have shown that both basalt and wollastonite are those substances that can act as fertilizers and stimulate plant growth. So that may be an added benefit of using those substances. The other thing that's starting to get a bit of interest in, I guess, enhanced weathering circles is the idea of using artificial silicates, basically silicate-rich waste materials. So it's things like mine tailings from hard rock mining, cement kiln dust from cement production, fly ash from coal-fired power plants, slags from iron and steel manufacturing. You know, the use of those substances is attractive because it would address sort of separate waste management challenges that we currently face in what to do with those materials. But there really hasn't yet been much research on what rates of carbon sequestration could be achieved, what the costs would be, and what other risks there might be. And the use of those so-called artificial silicates could also raise some really significant legal issues. As a sort of general rule, the legal framework for enhanced weathering is highly uncertain. There are no international or US federal or state laws that deal specifically with enhanced weathering, but depending on where and how they are performed, enhanced weathering projects could be subject to a variety of sort of general environmental and other laws. Listed some, but by no means all of them on this slide. At the international level, one potentially relevant instrument is the Convention on Biological Diversity. The convention itself, of course, doesn't say anything about enhanced weathering or carbon dioxide removal more generally, but the parties to the convention have previously expressed concern that those sorts of activities could affect biological diversity. And in 2010, they adopted a decision which recommended that countries avoid what they classed as geoengineering activities until there was a stronger scientific basis on which to justify those activities and a better understanding of the environmental and other risks they present. For the purposes of that decision, geoengineering was defined quite broadly, and I've put the definition on the slide. It could encompass things like enhanced weathering. But you know, as I said, it's just a recommendation and the decision itself is non-binding. So unclear how much, sort of, if any, practical impact it will have. There are also some other international agreements that could apply to enhanced weathering, particularly at sea. So agreements regarding the dumping of materials at sea and marine pollution more generally. The situation is even more complex at the domestic level. Again, no sort of specific laws or regulations dealing with enhanced weathering, but a number of potentially applicable general environmental laws. So, for example, enhanced weathering projects could be regulated as a source of particulate matter pollution under the Federal Clean Air Act and state rules adopted under that act. It could be regulated as a discharge of pollutants into waters under the Clean Water Act. And if you're using artificial silicates, it could be regulated as a form of waste disposal under the Resource Conservation and Recovery Act, RCRA. As well as those sort of environmental regulatory regimes that could apply to enhanced weathering projects, there's also some really complex issues around, for example, access to land. That's a particular issue for enhanced weathering projects on federal and state lands, but could also be there could also be issues for projects on private land, particularly agricultural land in areas where there are so-called agricultural preservation laws which restrict non-agricultural types of land. There are also questions around whether people who engage in enhanced weathering could be liable, for example, in trespass if the materials that are applied to land move onto neighboring properties. And then if you actually want to commercialize an enhanced weathering project and use it, for example, to generate carbon credits, there's really difficult questions around monitoring, reporting, and verification. How do you actually measure how much carbon dioxide has been captured and verify how long it remains captured for? So I'm happy to talk more about any of these issues, but for now, I think I'll leave it there and we can go to questions.
All right. Thank you very much for that, Romany. So as I said, I'll just ask you a couple of questions, and then I encourage everyone to start populating the the chat box with questions for Romany. But just a couple of things I was curious about, Romany. One of the things that you had talked about in the context of ocean-based or coastal-based enhanced mineral weathering was the Clean Water Act and potential regulations in that context. One of the potential impacts of enhanced mineral weathering is in terms of acidification, and I was wondering if there might be either state-based or federal-based pieces of legislation that would be pertinent in that context, and how that might play out in terms of regulating these activities.
Yeah, I think the sort of water implications broadly of enhanced weathering raise some really significant and somewhat uncertain issues. You know, the Clean Water Act could apply in a number of different ways, particularly to runoff from these sorts of activities. One of the sort of almost goals of enhanced weathering is that there will be runoff from these sites, and that will transfer the carbonate and bicarbonate ions into the oceans. And so you necessarily have this runoff that could affect aquatic water bodies and could be subject to regulation under the Clean Water Act, depending on how it is channeled and where the runoff's coming from. And so that's, you know, I think that's a perfect example of just how much uncertainty there is, and just how much the legal framework will depend exactly on the exact design of the project. One thing I would say is that there is a potential advantage for projects on agricultural lands, because you know, activities on an agricultural land and runoff in particular from agricultural land is exempt from the Clean Water Act, and so that could be you know, a particular advantage of operating in those areas.
All right, thank you for that. In your discussion of the potential implications of the London Convention, one of the conclusions that you draw is that it's possible under the London Convention that that enhanced mineral weathering might not be permitted full stop, given some of the potential impacts. Could you expand a bit on that?
Yeah, so both the London Convention and the protocol to the London Convention apply to the so-called dumping of materials of waste or other matter in ocean waters. And the definition of dumping is quite broad, really includes the deliberate disposal of materials into the waters, but there's this exception for the addition of materials for purposes other than disposal, where that's consistent with the purposes of the convention and the protocol. And so there's this question about whether enhanced weathering constitutes disposal for the purposes of the convention and the protocol, and whether it's consistent with the purposes of those instruments. You know, I think there's at least an argument that it's not disposal, because you're not doing it to sort of get rid of the materials. You're doing it for this purpose of mitigating climate change. But at the same time, it may not be consistent with the goals of the London Convention and the London Protocol, because those instruments are really very focused on marine protection, and we really don't yet know enough about the potential risks associated with enhanced weathering in the oceans to understand whether it is consistent with protecting those water bodies. So that's, you know, a potential, it's an area of uncertainty, but it is a potential stumbling block that could be an issue for some of these projects.
You know, if under the London Convention there's any kind of comparative sort of assessment, for example, you could argue that enhanced mineral weathering potentially could have negative impacts in terms of ocean ecosystems, but given the impacts of unchecked climate change on ocean ecosystems, could it be construed as still being consistent with London, because on balance it results in a net benefit in terms of ocean protection?
Yeah, I mean, to my knowledge, the London Convention has not been sort of applied in that sort of way in the past. And so, recently the parties to the convention and the protocol adopted this sort of resolution on ocean fertilization, which to some extent alluded to those sorts of considerations, but ultimately determined that, fertilization shouldn't be pursued at this point in time, given the state of the science, and that further research was needed. And I think a similar approach would be taken to enhanced weathering. There's just too many uncertainties as to whether the benefits outweigh the risks at this particular point in time.
Okay, thank you very much. Well, we have a lot of questions already, which is great. So I am going to seed the turf and start working through those questions. First question is, can you speak to legal issues around application of olivine to beaches? There would seem to be environmental permitting barriers is the comment here.
Yeah, absolutely. And, beaches are a very commonly discussed option for enhanced weathering because the tidal motion sort of agitates the materials, and that constantly sort of turns them over, creates new reactive surfaces, and so speeds up the mineralization weathering process. So there's a lot of interest in the potential for enhanced weathering in coastal areas. It does raise some really thorny legal questions. One is around access to land. A lot of those coastal areas are state-owned, and so you need state approval potentially from the relevant state land managers. In some cases, local governments have a role in the management of those coastal areas, so they also need to be engaged with. And then you have potential sort of environmental regulatory issues on top of that, the Clean Water Act being one of them. The potential again for runoff into the oceans from those sites. So yeah, definitely a lot of legal issues there. I think it's fair to say that in most cases, these legal issues are not insurmountable. It's, obtaining relevant permits, complying with, discharge limitations and things like that. So they're not prohibitive, but the fact that there are sort of so many issues to navigate and so much uncertainty as to exactly how these laws apply could create some challenges for project developers and really create time and cost issues.
Okay, all right, thank you for that. Next question, assuming that enhanced weathering can be done without insuperable adverse environmental impacts, even if that's true, the comment is we're talking in terms of hundreds of billions of dollars annually. Do you explore in your work or otherwise have thoughts, therefore, as to who should foot the bill?
Yeah, I mean, that is not something that I personally explore in my work, but it is a great question as to how we pay for this and other carbon removal techniques. It's commonly said that we should, there's a lot of interest in using these sorts of projects to generate carbon credits or offsets that can then be sold to businesses and others that want to reduce their carbon emissions or offset their carbon emissions. There's a real challenge with doing that in the enhanced weathering space, at least at the moment, because as I said, it's really difficult to determine exactly how much carbon is being sequestered and how long that carbon remains sequestered for. So there's real challenges around sort of monetizing, if you like, these sorts of technologies and how we pay for them.
Yeah. Does that imply then, if we were talking about the possibility of carbon credits, for example, beyond voluntary carbon markets, that there might be a role for regulation then under the Paris Agreement itself, right?
Yeah, potentially. I think that could be really useful. The Paris Agreement includes this Article 6, which provides for international trading of credits effectively, but there's still a lot of uncertainty as to how that trading framework will work. That was one of the issues that was sort of left out of the Paris Agreement rulebook that was adopted a year or so ago, because the parties could not reach agreement on it. So there are, some really, I think, complicated legal issues around, as I said, sort of measurement, monitoring, verification, and something that action at the international level could be very useful on.
Great, thank you for that. Next question. Most artificial silicates can be converted from a waste into a product. Carbon 8 is doing this, but it took them some years before the legal framework was established, and indeed it is leaching less than the unreacted product. I guess that's just a comment.
Yeah, you know, as I said, using those artificial silicates has a lot of benefits in terms of sort of addressing waste management challenges. We have these huge stockpiles of things like mine tailings that are, as the person alluded to, leaching into groundwater and things. And so making use of them could be really, really beneficial. The particular challenge with enhanced weathering using artificial silicates is that under the terms of the Resource Conservation and Recovery Act and the regulations issued under that act, the use of those materials for enhanced weathering could actually be considered a form of disposal because the materials are being applied to land. And if that's the case, then you run into a whole additional range of regulatory requirements, restrictions on where it can happen, rules around sort of the handling of those materials that are very, very complicated and could create some barriers for certain projects in certain places.
Okay, thank you. Next question. Do you have any information on enhanced weathering using biochar for either land or water usage? The comment is biochar was recently recognized as a carbon capture technology by the IPCC.
Yeah, there has been some interest in biochar. I think it's the sort of research around it and the thinking on it is less advanced than some of these other techniques, including enhanced weathering. Haven't seen a lot of discussion of it in the enhanced weathering space specifically, though.
Okay, great, thank you. Here's a question that I was also curious about. What impact could the proceedings on the BBNJ have on the discourse in the marine realm? What would a legal text need to look like in order to allow for enhanced weathering?
So, you know, to some degree, a lot depends on where you're doing this in the oceans, of course. If you're operating in the US, there's some domestic laws that apply, including something called the Marine Protection, Research and Sanctuaries Act, which you know, is relatively permissive of this sort of activity, but does have some hoops to jump through. If you're operating sort of beyond US waters, there are sort of rules under the London Convention and the London Protocol. But, you know, all of these, and this is a general point about enhanced weathering generally and carbon removal more generally, you know, these laws were really not developed for these activities, and so they're not a particularly good fit either to facilitating the activities or managing their potential negative impacts. So to my mind, the sort of best approach if we're thinking about a new legal framework for this is to design something that is more specific, more tailored, and can address, you know, takes into account both the benefits and the potential risks of these approaches.
Mm-hmm. Yeah, I think BBNJ's development will be interesting in this context. I mean, there's provisions for, you know, areas for sanctuaries, right, that might limit these activities, and transboundary environmental risk assessment, right? So yeah, it'll be interesting to watch. So thanks for that question. Next question. Are you familiar with the Half Earth Plan, also known as the Global Deal for Nature? If so, what are the legal and financial constraints with that plan, given that it would be a major solution to both climate and biodiversity issues?
I don't think I can comment on that one. It's a little bit too specific, I'm sorry.
Okay. So can you comment on the relation between law and public acceptance on this topic?
Yeah, I think, you know, the two are, of course, closely interlinked, and a particular issue in carbon removal generally. I think there are particularly thorny issues around carbon removal and enhanced weathering in the oceans from a public perception point of view. You know, we have these largely untouched areas that I think many people do not like the thought of doing these sorts of interventions, if you like, in these sort of very pristine areas. And so I definitely think that's a challenge. I think that has, to some degree fed into why we have seen this very cautious approach to some of these carbon removal techniques in ocean-based environments at the international level, for example, through the London Convention, the Resolution on Ocean Fertilization related measures. So, you know, I don't think that one can overstate the importance of consultation and engagement with local communities, particularly in the oceans context, but that can also be really important on land as well. You know, if we're thinking about liability issues, you know, consulting with neighboring landowners by these activities can be hugely important in you know, mitigating some of those risks. So definitely the social acceptance and broader sort of political, socio-political environment in which these activities occur is hugely important.
Right. And could you, in that context, could you speak a bit about the public engagement sort of options that are provided for under some of the statutes that you think might be pertinent, at least in the United States, like Clean Water Act or Clean Air Act?
Yeah, I mean, there are certainly, you know, when we're thinking about permitting regimes in the United States for some of these activities, Clean Air Act permits or Clean Water Act permits, there are, and state sort of equivalent environmental permits. There are often public consultation provisions built into that. There are public notice sort of processes built into that. You know, my own view is that those are not sufficient and for these sorts of activities that are so new, so unknown to many people, and I think in many cases elicit a very sort of strong reaction from people. So certainly those things are important, but not sufficient in themselves, in my opinion.
Do you think, given the fact that that unlike a lot of interventions at the domestic level, where the activity's impact is primarily going to be either localized or at the most national, if you have an intervention of this sort that could alter the world climate, would that indicate that there should be a broader requirement in terms of public engagement and deliberation? And what might that look like? Do we have mechanisms to facilitate that under, like, US law, for example? If we were going to do something that could profoundly impact the global commons, is there provisions for public deliberation beyond US citizens?
Yeah, it's a really interesting question. You know, there's this question about if we're reducing temperatures by 0.1 or 0.2 of a degree, and that obviously has an impact on other places as well. How should we be engaging with the international community on that? You know, there are, I think, I would say that, you know, getting to that scale will be, as you know, well, you know, an incredible, that's not easy to do. This scale of enhanced weathering that would be required here in the United States to have a sort of noticeable impact on global climate, I think is pretty significant and difficult to achieve. There are provisions under some of the international agreements for sort of cross-border consultation, intergovernmental consultation on some of these things, and particularly with respect to the oceans. You know, the United Nations Convention on the Law of the Sea and other international agreements have provisions around sort of consultation regarding activities that could affect other states, and you know, the US EPA has a somewhat established process for consulting with other governments about ocean dumping and things like that, but you know, they're certainly not, I wouldn't say well established, and it's certainly not something that, you know, we have had to do regularly in the past. So there will be a certain element of sort of newness to doing that.
Okay, great, thank you for that. Okay, next question. Some countries are tightening their rules around agricultural runoff, mainly due to concerns about environmental impacts of nitrates. Could the agricultural exemption for runoff conceivably vanish in the future, and is this considered as a potential risk by developers?
I haven't seen any developers talking about that specific issue, but I think it's sort of honestly too in the weeds for where most developers are at this point in time, thinking about these technologies. You know, we're still very much in a research focused position. You know, I think whether the agricultural runoff exemption under the Clean Water Act could be removed, certainly a possibility. I think the agricultural industry in this country is incredibly powerful and has incredible influence in Congress. So it would certainly not be an easy thing to get removed. But, you know, we have for many years seen and we continue to see more and more concerns about agricultural runoff. So, you know, I wouldn't dismiss it entirely, but I'm not holding my breath.
Okay, thank you. Next question, what is the pH impact of enhanced weathering on soils and on oceans?
Yeah, so one of the, I mean, I will premise this by saying that I am not a scientist and I have a rudimentary understanding of chemistry. But, you know, one of the benefits and one of the sort of selling points of enhanced weathering is that it can actually sort of change the chemistry of ocean waters and be used to counteract the problem of ocean acidification. And so that actually allows the oceans to absorb more carbon dioxide naturally. And so you sort of get this double benefit from doing this, particularly in the oceans, but even if you do it on land, the runoff, because you necessarily have some runoff of these carbonate and bicarbonate ions into the ocean waters, that can have a similar benefit.
Okay, thank you for that. Let's see. Okay, let me move up my list here. Let's see. So another technical question, so you may or may not want to take it, but what does the energy budget look like? Does this take a lot of energy for transport, grinding, and so forth?
Yeah, so there hasn't been a huge amount of work done on that specific issue. Most of the discussion around energy budget has centered on the grinding piece, because of course, the finer you grind the materials, the more energy that needs, but more, and so if you're, you know, particularly if you're getting that energy from fossil or other polluting sources, then that's an issue. But on the other hand, the finer the grains that you end up with, the faster and higher the rate of carbon sequestration. So there's this sort of trade-off there. Most of the studies that I've seen have sort of proposed using sort of mid-sized grains to sort of manage those two, balance those two competing considerations. There are also issues around transportation. You know, we do have many places in the world have, you know, existing infrastructure for transporting these sorts of materials. So, you know, we can sort of take advantage of that. But if you're wanting to do this on a very large scale, transportation would necessarily be an issue, and you'd need to be thinking about doing transportation in a clean, climate-friendly way, so as not to offset the benefits of enhanced weathering.
Okay. All right, thank you. Next question. There's a number of protocols for quality specification for biochar and an expectation that it joins categorization as an EU fertilizer, according to such protocol. So this is quite a lot more advanced than for mineral weathering, surely?
Yeah, I'm not hugely familiar with the specific rules around biochar, but it certainly sounds more advanced. We don't have anything similar for enhanced weathering.
Okay. Let's see. Next question. Do you think it is important to get a financial support to make, hold on, I'm just trying to, I think this question got garbled, unfortunately. So let me just move on to another one first. If minerals are acidic, wouldn't ocean applications increase the threat of carbonic acid to corals and shellfish?
So that is one of the potential risks that requires further study. There really hasn't been you know, this is a new idea, relatively new idea, and while it has been getting a lot of attention in the scientific community, there are still some unresolved issues, particularly around sort of the environmental risks on water bodies and aquatic ecosystems. But that's certainly something that people have flagged as a potential issue.
Mm-hmm. Could you expand a little bit more on what some of the other risks that are being talked about in the context of marine-based weathering?
Yeah, marine-based, you know, we mostly hear about risks to, we mostly hear about sort of increased turbidity, changes in sort of ocean chemistry that could affect, you know, living organisms that have sort of adapted to the existing sort of chemical structure of the oceans. They're sort of the main risks that we hear about. On land, we hear about similar things, you know, turbidity and existing in sort of surface waters, issues around water contamination, potential soil contamination, as I said, from these sort of trace elements in the rock. And the other thing that we hear a lot about is the risk of inhalation of the silica particles, particularly when inhaled by humans. They can cause, you know, reduced lung function and other lung problems, as we've seen in miners in the past. So that is definitely a concern, and ties into the point I was making earlier about the particle size is again really important, because the finer the particle, the better from a carbon sequestration perspective. But you know, the finer particles are also more easily inhaled and potentially sort of more of a risk to public health.
In that context, you go through a fairly, no pun intended, granular discussion of the different regulations that would be pertinent in terms of the micron size of those particles. Could you just briefly summarize that in terms of what the regulation would look like, anywhere from like 2.5 or beyond 10?
Yeah, so under the Clean Air Act, you know, there's the EPA is responsible for regulating these so-called criteria pollutants that are basically come from many sources and pose a threat to public health and safety. The EPA has sort of designated two classes of particulate matter as criteria pollutants. One is PM 2.5, which is particles of 2.5 microns or less in diameter. And the other is PM 10, which is particles of 10 microns or less in diameter. And there's different sort of what are called national ambient air quality standards for PM 2.5 versus PM 10. And there's those sort of translate into permitting requirements and other things to prevent particularly high levels of those substances. I will say that some states, because the states can go further than the federal government in terms of their regulation, some states have additional rules for larger particles. So some states, you know, if you're thinking about a rock grinding operation, if that produced particles that were smaller than 10 microns in size, that would need to be permitted under the EPA rules. But some states have rules that require rock grinding operations producing any size of particles to be permitted if there's a certain amount of flow into the air, basically. So yeah, there are very different rules depending on the size of the rock particles that you're dealing with.
All right, thank you very much. Next question. Does it make a legal difference if the materials are entering into international rather than coastal waters? If so, should we be trying to understand better where exactly the materials end up when they enter the ocean?
So it potentially makes a difference if you're depositing them into international waters rather than coastal waters. If they flow into international waters after having been deposited into coastal waters, I don't think that makes a difference. But there's sort of a caveat on that. For example, if you're here in the US, as I said, we have this Marine Protection Research and Sanctuaries Act, which basically implements the London Convention domestically. And that law applies to activities involving the discharge of materials into ocean waters. It applies to any discharge in US coastal waters near to shore. It also applies to discharges elsewhere if they come from a US registered vessel, or if the materials that you're using were loaded in the United States. And other countries have similar laws that apply to vessels registered in their countries or loaded in their countries. So even if you're depositing these materials in the open ocean on the high seas, you could still potentially be subject to these sorts of laws depending on where you put the materials on the ship and where your ship is registered.
All right, thank you. Next question. If the legal framework that applies depends on the purpose of the activity, but there are potentially multiple reasons and incentives for enhanced mineral weathering, such as fertilization, how do you decide what laws apply?
Yeah, it's a really good question. A number of the laws, if we're thinking about on land, this is something that comes up particularly when we're talking about enhanced weathering on agricultural lands, and we're thinking about what those lands can be used for, because as I said at the outset, some states and localities have adopted laws that restrict the use of land for non-agricultural purposes. And so there's this question, is enhanced weathering an agricultural activity? Because it has these sort of dual purposes, as you say, of mitigating climate change, but also acting as a fertilizer and stimulating plant growth. There's no sort of set rules around how that decision is made. I think there's a really strong argument that because we do have these sort of co-benefits, if you like, that these sorts of activities should be assessed based on all those benefits and all those reasons for doing this. And so that should be really helpful when we're thinking about compliance with those sorts of things. I would say in the ocean space, the situation is a little bit different because we sort of have these laws that deal specifically with disposal of materials in the ocean. And so we really need to think, so the question is really, are you disposing of something or are you not disposing of something? And that's a difficult question to answer, and more difficult than it sounds, but has a, I think, clearer answer once you reach it. If that makes sense.
Thank you. Next question. Given that research is expected to obey the London Convention, do you see current problems with conducting field experiments on weathering in the marine realm? If so, how should the scientific community address these? So now we're looking at research more specifically than deployment.
Yeah, so I think as a general rule, the international community has been somewhat more open to research-based projects, and there's a recognition implicit in a lot of the international sort of decisions and resolutions that have been adopted on carbon removal, that there is a need for further research. Currently under the London Convention, we have this resolution specifically on ocean fertilization. It doesn't apply to other types of carbon removal like enhanced weathering, but in practice, enhanced weathering and ocean fertilization are very similar. They involve sort of the same basic type of activity for the same basic purpose. And so we can imagine sort of the international community taking a similar approach to enhanced weathering. But sort of there is no sort of set protocol, I guess, for research around enhanced weathering in the oceans at this point in time.
Right. And if just to summarize what happens in the London Convention, if somebody wished to engage in an enhanced mineral weathering experiment, and assuming London concluded that the same sort of rules should apply as for ocean iron fertilization, what would be the constraints and the requirements for that kind of activity under London?
Yeah, there's quite detailed rules around the sort of requiring a sort of pre-review of those activities, an assessment of sort of what's actually involved, the risks, and sort of a very detailed environmental review, if you like. So I can imagine that we would see something similar for enhanced weathering research type projects, if they were proposed and subject to a similar sort of regime, if you like.
Okay, great, thank you. I was wondering if it'd be possible for you to, I don't know what stage you're at, but I know you're working on another report that looks at the extractive elements of this, right, and the laws that would apply. Have you drawn any conclusions yet in that context in terms of that, or just share where you're going with that report?
Yeah, so the report will look at basically sort of material sourcing for use in enhanced weathering, both issues around the mining of donite and other rocks, and the processing of those materials. So, for example, the grinding and so forth. You know, I think for those natural materials, you know, there's an established sort of legal framework for hard rock mining and for grinding and processing, and actually many of the same sorts of general environmental laws will apply to those activities. The more, I think, complex issues arise around those, and particularly mine tailings. You know, there are real questions about who owns those mine tailings that are currently stored in big stockpiles around the country. How people could obtain a right to use those mine tailings for enhanced weathering. That's one of the, I think, most interesting aspects of the paper, you know, because in a lot of cases, those materials have effectively been abandoned and are just sitting on land that might be federally owned, might be privately owned. So there's sort of will be a big component of the paper, which we're just starting to dig into at the moment.
Yeah, I think that'll be fascinating because I know a lot of people are quite excited about the possibility of using waste, both because it's a way of disposing of it, but because it reduces the energetics potentially of this. But obviously, it sounds like there might be lots of other imposing sort of regulatory barriers in that concept. So we'll look forward to that.
Yeah.
We're nearing our end. I was wondering if you had any concluding thoughts that you wanted to share with us before we adjourn.
I would just say that I think this is, like so many techniques, this is an area that really requires more attention from the legal and policy community. You know, as I said at the outset, there's huge potential here for carbon sequestration, but actually doing it will be very challenging, including from a legal perspective. You know, we have this kind of patchwork of laws that could potentially apply to projects. None of those laws were developed for this particular type of activity, and in a lot of cases they're pretty poorly suited to it. So this is an area where we really need legal attention and legal action, both to facilitate these sorts of projects, but also to ensure that their risks and potential negative impacts are appropriately managed.
All right. Thank you very much for that, Romany. And again, thank you in general for an excellent presentation. And I'd like to thank everybody who has joined us for the excellent questions. As Allison indicated, this webinar, as is true with all of our webinars, will be archived on our site and is usually available within a week or so. We always want to encourage people to share that archive with others that might be interested in this topic. We will continue to look at legal issues of this nature, and hopefully we'll have Romany back when she is done with the next report in this context. So thank you everybody again, and with that we will conclude this webinar.
Thanks, Will.
Bye now.